Okay, 5-6 today, parallel and perpendicular lines. Let's get out the note packet. Okay, and something that I just copied for you on this note packet was the key concept of a parallel line. So parallel line, remember that slope.
They don't touch.
They don't touch, right? Ever. But the slope of the line, I don't want you guys to forget that that really means how steep the line is, right? So if lines are parallel, do they have the same steepness?
Yes.
They do. So the idea, the key concept here is that slopes of parallel lines will be the same. So they will have a different y-intercept, the same slope, okay? So slopes of parallel lines. So parallel means slopes are the same, but the y-intercept has to be different, okay? Because if you think about if the y-intercept is the same and the slope is the same, what's going to happen then?
It's just going to be
It's going to be the same line, isn't it, right? If the y-intercept and the slope are the same, which that's a thing, right? If you end up that way, there's a word for that. If you can have two lines that have the same slope and same y-intercept, the number of solutions is infinite solutions. It means that those lines are the same for every single point. Okay, so let's focus on this first problem then. So the problem 1 says this. Writing an equation of a parallel line. So it says a line passes through this point, 12, 5, and is parallel to the graph of y equals 2/3 x minus 1. What equation represents a line in slope-intercept form? So remember, slope-intercept form is y equal mx plus b. And according to this, it's got to be parallel to this line. So what part of this has to be the same? The slope. So this, we know m has to be 2/3, right? And then we have a point that is on it. So what we don't know is our b value or our y-intercept. So what we're going to do is we're going to make that 2/3, and this is going to be like when we give you the slope in an ordered pair, right? And you got to figure out y-intercept. You're going to fill in y and x with what's given. So y is 5 equals, we know slope's got to be 2/3, x is 12, so we're going to say times 12 plus b, and we're going to solve for that y-intercept first. Okay, so this has to get multiplied. 2/3 times 12 equals what? And the quick way to multiply is realize this is 12 over 1, right? So 12 times 2 is 24.
So it's 8.
Over 3 is 8. That's right. So we really have 5 equals 8 plus b. And at this point, you can either use the algebra and subtract 8, or you can do it in your head. 8 plus what number is going to give you 5?
3.
Negative 3. Yep. Okay. If you don't know that, you subtract 8 to cancel it. Subtract 8 here, and you get 5 minus 8, b equal negative 3. That's the information you need now to write the equation. The equation now is y equals, what's the m got to be? We already know. 2/3, yep. X, and now what did we just decide b was? Negative 3. So you can either say minus 3 or plus negative 3. They both are the same. So this is the answer. This will be parallel to this, okay? This one will cross the y-axis at negative 3. This one will cross at negative 1, and they will be parallel. Yeah.
I mean, if we put both of those, in the calculator.
So yeah, you can. That's a good way to check it, actually. So to check it, you could put both of these in the calculator, and they should graph exactly parallel lines that never touch when you do it. So to check your answer, that is always a good way to do that. And I'm going to show you some others that you can just use the graphing calculator to get the answer too. All right, so that's the first one. You guys checking it out? Did it work? Should have. Okay, I'll go to them after this. All right, the other thing now is the slope of a perpendicular line, okay? So perpendicular, first of all, means that they cross at a 90-degree angle. So look at this. And I copied this on here. Oops. So perpendicular lines look like this. Now the slope of perpendicular line, here's the words. Two non-vertical lines are perpendicular if the product of their slopes is -1. So that's really hard to think about in words. So what this means is the slopes have to be the opposite reciprocal, okay? So we'll write that down and then I'll talk about what that means, okay? In this case, the y-intercept doesn't really matter. The only thing that matters is the slope has to be the opposite. And what I mean by opposite is if it's positive, you gotta the other one has to be negative or vice versa. And reciprocal, what does that mean? What's a reciprocal? Go, Cody. The flip version. Okay, so here's an example. Let's give an example over here. So for example, opposite reciprocals would be this. If the first slope, like the one above, is 2/3, let's say. The opposite reciprocal of 2/3 would be -3/2. So you gotta flip the numbers and you gotta make it opposite. Now, the way you can check to know if you have the right answer here is if you multiply these two, you should get -1. Okay? So positive 2/3 times -3/2 gives me -6/6, which is -1. That's how you check it. That's what they mean right here, where it says the product of their slopes is -1. Okay? That means that the slope of the line, so you get a line, the slope of the perpendicular line has to be the opposite reciprocal. Okay, let's do this then. So here's an example of, let me make sure I'm on screen. Yep, I am. Okay. Here's an example of a question that you would see. So it says, are the graphs of 4y equal -5x plus 12 and y equal 4/5 x minus 8 parallel, perpendicular, or neither? Okay? And so we check that. So you can get a neither if the slopes are not the same or if they're not the opposite reciprocal. It's a neither. Okay? So the problem is, one of these two, we can't see the slope yet. Which one do we have to solve for the slope on? Xavier, go. That's right. So 4y equal -5x plus 12. We got to solve for the slope. So what do we have to do to solve for the slope? Starts with a duh and ends with a divide. By what number? 4. Okay? We have to make it in y equals format in order to go, oh, that's the slope, right? It's got to be y equal mx plus b. So I'm going to divide that 4 out of there and divide this by 4 and this by 4. Now, do I really have to simplify it?
No.
What's the slope of this line that I just did? -5 over 4. This is the slope of this line. What's the slope of the other one listed? 4/5. Are those opposite reciprocals?
Yes.
They are, so that makes them perpendicular. Makes sense? So if you were to put this in your calculator, let's simplify this. Y equal -5/4x plus 12 divided by 4 would be 3. And this one, y equal 4/5 x minus 8, if you put those two in, they should cross and make like 4 perfect 90-degree angles around it. That's what it means to be perpendicular. They should be exactly crossing like the one pictured here. Okay, and so you want to use your graphing calculator sometimes to get the answer, but sometimes, especially if you're on a test or something that matters, worth a lot of points or worth something on SAT, use that graphing calculator to check your work and be sure. All right, so far so good? No?
Yeah.
Okay, let's finish the notes, and then if we have questions, I will help you guys on the homework today, okay? All right, problem 3 is on the other side. So it says, and this was multiple choice. So this is a great example of a PSAT or an SAT question right here. It says, which equation represents the line that passes through 2, 4 and is now perpendicular to the graph of y equal 1/3 x minus 1? Okay, so we have a lot of information here. So in order for it to be perpendicular, what does the slope have to be of our new line? Okay, raise your hand if you know what the slope of the new line should be. Go ahead, Xavier, what do you got? -3, yes. Because if you flip that around, it's really -3/1, and he simplified it. It's -3. So right away, looking at your answer choices, if you were on a test, you know it's not A and it's not B. Okay? Now, the question is, what's our y-intercept? Is it -2 or +10, right? And so what you have to do is you're going to have to figure out, okay, what it's got to pass through this line right here, okay, or through this point 2, 4. So if you do this, y equal mx plus b, and you fill in y, m, and x, so y has to be 4, right, according to that. What does m have to be? -3 times our x value, which is 2, plus b. Well, -3 times 2 is what?
6, -6.
Yep, -6 plus b. And then if you add 6 to cancel that out, 10. b equal 10. We know it has to be answer choice D. And again, you could type this in your calculator and type this in your calculator, the two equations that the answer you got, and the original, see if they're perpendicular. Okay, and that's how we check our work. All right, last but not least, everybody's favorite, story problem. Woo!
Yeah.
Joy, joy, joy.
Help me.
Everybody loves story problems is what you mean. Okay. So some of you in this class, I do believe, may become architects. All right? You will use software to help you, but also you got to know the math. Okay? So here's an example. An architect uses software to design the ceiling of a room. The architect needs to enter an equation that represents a new beam. The new beam will be perpendicular to the existing beam, which is represented by the red line. I know you can't see that it's red, so I'll make it, but this is the existing beam. Whoa. Sorry about that. I'm just highlighting it. The new beam will pass through the corner represented by the blue point. So this would be the corner. What is an equation that represents the new beam? So if you're an architect, you've got to make sure things are perpendicular, especially with beams, so that the structure is solid and not going to collapse, right? So the roof is important, especially in spaces like Michigan where we get a lot of snow. Now, here's what we got. So on our first one, it needs to be perpendicular. So we need to know the equation for the red line. Or at least the slope, don't we? Okay? How do we find the slope of the red line? Starts with an R. Go, Xavier. Rise over run. Let's go. Okay, and I'm going to do that right here. So our slope, our rise over run here for the red line, you got to pick two spots. So this is right on the line at 8. Okay, and I should probably use a different color so we can see. Right? And if we're unsure, we could use all the way at 12, but look at where does it cross another corner? It looks like right here, right? So what's my rise? -2, good. What's my run?
3.
3. So that, for my line to be perpendicular, what does my new slope for my new line have to be? So my new slope has to be what? Raise your hand if you know. For perpendicular, what does my new slope have to be? Emma, go. +3/2. Good. Okay. So, y equal mx plus b. Where do my x and y come from? I know my new slope is 3/2. Where do I get x and y if I know that my new beam has to be perpendicular starting at this blue point? Where does our x and y come from? Go ahead, Emma.
The point, so it'd be 12, 10.
That's right. This point right here is 12, 10. That's the point it's going to start at. So my y value is going to be 10. My x value is 12. And I'm going to solve then for b, okay? Remember to do this in your head and quickly, right? This is really 12/1. So 3 times 12 is? Divided by 2? 18. 10 equal 18 plus b. All right, you could probably do that in your head. What's the value of b? You could subtract it. -18. -18. -8. b equal -8. So what's the equation of the new line that this architect has to enter into his software? The software is not going to do that part for him. He's got to do that part. Alvin, go ahead.
Y equals 3/2x minus 8.
Good job. And if he doesn't do that correctly, that's going to be a problem all the way down, right? If he doesn't do that correctly, someone's house is going to be in bad shape. Now, in the real world, the way architecture works is you've got your architect and then you have someone who checks, right? Because you don't want such a catastrophe to happen. So there is someone that does it, and then there's someone that checks it. So that you do have that going for you. Okay, that's the lesson for today. So we'll post this for anyone that missed it. And then our assignment today is going to be 5-6 practice, but we're only going to do the even numbers.
All the way to what?
To the end, because they're all over your next test.